the Medieval Climate Optimum and the Little Ice Age. East Sussex. What was the Medieval Climate Anomaly? The Medieval Climate Anomaly was the most recent pre-industrial climatic warm era in Europe. This climate anomaly was not caused by humans, but occurred as a result of natural variability in climate, unlike climate changes occurring today. Historical environmental change affected water supply, agricultural productivity, and human health. It also provoked civil conflict and unrest. England before the medieval climate anomaly. England experienced increased climatic variability between about 250 to 600, which stabilized by the 7th to 9th centuries, thereby allowing for economic and demographic expansion. In fact, settlements boomed in this period, and in consequence, the English converted many forests to arable farmland in order to grow food for the expanded population. The medieval climate optimum. From 700 to 1000, England experienced warmer summers, allowing for sustained demographics. Rapid cultural and political growth accompanied humid and mild summers. Average precipitation and temperature data shows fewer fluctuations between 1000 and 1200 than there had been between 700 and 1000. During this great warming period in England, farmers were able to push cultivation 60 meters higher than today, and to grow hardier grains such as oats, barley, and rye at the coolest margins of the continent, such as the Highlands of Scotland. Viticulture, grape cultivation, extended as much as 500 kilometers further north than today's commercial vineyards. This meant that, at this time, southern English farmers were able to cultivate grapes for wine. During the medieval climate optimum, the English population tripled. The Little Ice Age. On a global scale, the Little Ice Age had begun by about 1250. Certainly, in England, there was a pronounced drop in winter temperatures by 1300, with the coolest temperatures occurring between 1400 and 1700. Average temperatures, moreover, became 1 degree Celsius colder, and the English growing seasons shrank by 3 weeks. Climate change also brought wetter weather, which lasted until about 1850. Evidence from the North Atlantic suggests additional rainfall of 20 to 40 millimeters per season. Finally, the altitude limit of crop cultivation and tree growth fell by 200 meters. All of these harsher conditions contributed to eventual states of famine in England and, indeed, across Europe in the 13th and 14th centuries. Because weather patterns became less stable and more challenging, crop failures and famine became more frequent. The Great Famine of 1315 to 1322 encompassed the northern half of Europe. Crop failures, cattle disease, elevated crime rates, sickness, and high mortality rates were all characteristics of this time. To make matters worse, the seas became stormier, fisheries disappeared, and glaciers advanced. In this way, we should not think of the climate of the Little Ice Age as being simply uniformly bad, but as being more variable. This variation posed multiple and complex challenges to human and other animal populations. Causes. The widespread signature of this climatic shift suggests changes in tropical sea surface temperatures, SSTs. The medieval climate anomaly appears to have occurred due to the interplay between Arctic air and the ocean waters that power thermohaline circulation. This process acts as a kind of heat pump for Europe, largely through the circulation or lack thereof of warm ocean currents caused by cyclical shifts in the Earth's orbits and axis. The relaxation from the medieval climate optimum into the Little Ice Age suggests a reorganization of large-scale oceanic and atmospheric circulation patterns. Other factors played their role. There was more extensive snow cover, for example. Ice and snow reflect solar heat, cooling the Earth's surface. Variations in the Earth's orbit, fluctuations in solar radiation, sunspots, and increased volcanic activity also caused dust veils in the stratosphere, which played a role in shifting climates. Volcanic activity only plays a small role in the changing of the climate. Climate scientists know that major volcanic eruptions often emit enormous volumes of volcanic ash into the atmosphere and have the effect of blocking the sun's radiation and cooling the Earth's climate. However, these changes are attributed to a 0.2 degrees Celsius change in a 2-year time frame. An example of this can be found in Scotland in 1783 when the Laki volcano in Iceland erupted. It was one of the largest outpourings of lava in the past 1,000 years, spewing out 42 billion tons of molten rock. Famines and haze spread across Europe, having a negative effect on population. After the medieval climate anomaly and into the present. Further climatic instability followed in the 16th century. During the period 1500 to 1530, annual temperatures were 0.3 degrees Celsius below the 1901 to 1960 average, and from 1560 to 1600, 0.5 degrees Celsius below average. Temperature minima in the early 17th and 19th centuries accompanied sustained settlement abandonment and the modern migration from Europe to the Americas. Climatic instability had occurred in the past and was natural. However, modern climate change is caused by humans and has catastrophic consequences. Climate change is already having visible effects on the world. The Earth is warming, rainfall patterns are changing, and sea levels are rising. These changes can increase the risk of heat waves, floods, droughts, and fires. The level of climatic change we will see depends on how quickly we cut emissions of dangerous greenhouse gases. Even if we were able to stop all emissions today, we would not prevent some changes. However, the sooner we cut emissions, the smaller the changes will be. Climate change is causing warming across the United Kingdom. All of the United Kingdom's 10 warmest years on record have occurred since 2002. Heat waves like that of summer 2018 are now 30 times more likely to happen due to climate change. The message remains clear. We need to cut down on emissions immediately.